All right, now we're going to move on to questions 6, 7, and 8. 6, 7, and 8 are factoring questions. We'd like you to solve these by factoring. So it's going to be similar to problems 4 and 5 on the topic, except 4 and 5 are already factored. So first we have to do what we did in questions 2 and 3 first, which is get the equation factored. Then, once it's factored like it was in questions 4 and 5, we'll just apply the zero product property and find our values of x. So in question 6, um, first this thing, of course, we should check for greatest common factor, and we've got a 1. As soon as you have a 1 for one of your terms, there's no number that's going to be common other than 1, and then there's not an x in both. You'll notice in this one there's only 2 terms. If there's only 2 terms in a quadratic, you'll want to check for difference of squares. And in a difference of squares, the first and last term would need to be perfect squares, which they are in this particular case. X is multiplied by itself, and 144 would be 12 times 12. The nice thing about a difference of squares is that it factors into what is called conjugates, which I know we've talked about quite a bit. We've even, if you were in my class, we actually heard a song, and this was the conjugate time. Okay, so remember the first term times the first term has to get you the first term, and the last term times the last term has to get you the last term. And again, the outers and inners are going to cancel automatically because one of these factors is going to be addition, one of them is going to be subtraction. So what times itself gets you x squared? That would be x. What times itself gets you 144? And that would be 12. So your factors of x squared minus 144 is x plus 12, x minus 12. And then in the final step, again, just like we did in questions 4 and 5, we take each one of those factors and set them each individually equal to 0. So that would get you x equals negative 12 as one answer, and x equals positive 12 as your second answer. Oops, sorry. Okay, let's move on to question number 7. In question number 7, we want to solve again by factoring, but you might notice that this is not set equal to 0 yet. So in this problem, we're going to need to move the terms, and we're going to want to make sure they go in the correct sequence. You'll always list your x squared term first, then your x term, your linear term, which we're going to bring over, and when it comes over, it's going to become positive. So this is going to be a positive 34x. And then you always list your whole number last, which in this case is 72, actually negative 72. And that's now equal to 0. So in this one, we'll look and we don't see a common factor since there's a 1 and there's not an x in all the terms. So since there's 3 terms, we know we're going to have to do the opposite of FOIL, sometimes referred to as guess and check. And remember that in the FOIL process, this is going to be your first term, this is going to be your combination of your outers and inners, and this is going to be your last term. So we know the first term times the first term gets you the first term, so that's going to have to be an x and an x. And we know the last term times the last term has to get you the last term. So we need factors of 72 that will get us 34. Okay? So I'm going to list some factors down below here. We're going to have 1 and 72. We've got 2 and 36. We've got, I think 3 goes in there. 3 goes into 7 once. And then there's 1 left over, so that's a 12, so that's 3 and 14. I think there might be some other ones, maybe 8 and 9. Okay. So what we're doing is we're going to look for these numbers that could get us 34. 1 and 72 is going to be tough to combine together to get 34, but you'll notice that 2 and 36, if you subtract 2 from 36, you can get a 34 that way. So that looks like this is going to be the set we're going to use. So since we want a positive 34, looks like we need a positive 36 and a negative 2. So let's put a plus 36 here and a minus 2. And we'll just double check this really quick. X times x is x squared. X times negative 2 is negative 2x. 36 times x is positive 36x. And of course, those will combine together to get you positive 34x, which is what we wanted. And then the last terms, 36 times negative 2 gets you negative 72. So we've got our quadratic factor. So here again, we got our final step here. And we might be able to start taking a shortcut here. If you don't have a term in front of the x, if your term in front of the x in each of the factors is just 1, this becomes quite simple to get your final solutions, because we're going to need the opposite of this number for the value of x in order for this to become 0. So if this is positive 36, then the x would obviously need to be negative 36 in order for that to equal 0. And then on this term, if this is a negative 2, then obviously x would need to be a positive 2 in order for that to become 0. So there's question number 7. Moving on, we have one more question here on the first page. And again, we want to use factoring to solve this quadratic. So on this one, we have to look for a common factor. We've got a 3, a 16, and a 21, and it almost looks like we have a common factor of 3, but unfortunately 3 doesn't go into 16 evenly. So we're unable to take out a common factor. And since there's 3 terms, it looks like our only opportunity will be to factor this into 2 binomials. And again, remember that we've got FOIL. So the first term is going to get you 3x squared. The most important part is that the outers and inners are going to get you that positive 16x. And the last term is going to get you 21. So first term times the first term gets you the first term. So that's going to need to be a 3x and an x, because we have no real options there for factors of 3. We know the last term times the last term has to get you the last term here, which in case is positive 21. In order to get to a positive, you would need 2 positives or 2 negatives, but since this middle term here is positive, our signs are going to both need to be positive. So now we need factors of 21. Factors of 21 would be 1 and 21, or 3 and 7. So we're looking for factors of 21 that could go here and here, but since we do have a number in front of one of our first terms, we have a 3, we know, and then the other one is 1, we know one of these terms here is going to get multiplied by that 3. And then they're going to get added together in order to get you 16. So if you try multiplying 3 times this 1, you get 3. 3 and 21 add up to 24. That doesn't look like that's going to work. And obviously if you multiply 3 times 21, that's going to be a very large number. Doesn't look like that one's going to work. So let's try multiplying the second set by 3. If we do 3 times 3, we get 9. 9 and 7 does get us 16. So it looks like that's the option we're going to need to use. So now we need to make sure we place these in the correct spot. We wanted the 3's to multiply together, so we're going to need to put the 3 here, and then the 7 will go there. And we'll just double check this really quick. 3x times x is 3x squared. 3x times 3 gets you 9x. 7 times x gets you 7x. And when you add those together, you do get 16x, which is what we wanted. And then the last term, 7 times 3 gets you 21. So there's our factors. And again, this one here, going to be a little tough to do mentally. The more you do, the easier this might become to do this mentally. But I'm going to show the work. We're going to have 3x plus 7 equals 0. Okay, so that means that 3x is going to equal, subtracting the 7, you get negative 7. So then divide by 3, you get negative 7/3. And you can just leave your answer as an improper fraction. It's very common. And for the second answer, again, since it's x plus 3, we can quite easily solve that one mentally, because we need the opposite of positive 3 in order to get 0. So in that case, it's negative 3. Okay, I hope that's helped for you for the first page of the review. And we'll, in the next video, move on to the second page.